Hello guys, this video is related to our quantity surveying assignment. So I'm going to tell you about the brickwork in a building and how we do. So this is the building I have in AutoCAD, and this is the building work I have done in the total sum up. So starting from the building work, it started from plinth level. For a plinth level, we have the diagram, we have the width. So if this is our graph. So this building I show you this building having the separate rooms with dimensions like different to have different dimension. It's a school building. So I have calculated the brickwork total brickwork in the building, and the total cement and plastering and painting. So starting from the base, actually we need to do break in the foundation for every wall. So for these walls, the brickwork is done individually for every. So from here, this is general building works. So brickwork in foundation up to plinth level. It's a these room sizes given. So these are the 6,000 rooms. These are the walls. So first we are going these perpendicular walls. So these perpendicular walls are calculated as 6,000 walls are total. It's given there. These are 28 walls, and the width we always take the width about 2.3. We can it depends on us how much we can take it, but it's a double, it's a load bearing wall. It wears its all self load, and these are final means water walls. So we can use we have to use it 2.23, and this is the height. The height below plinth level is 1.15 meter, and this is the length is 6 meters. So these are 6 meter walls. For 8 meter walls, we have these 8 meter walls for the big rooms. So these walls are total 2 in number, and this 8 meter walls distance is a it's 8 meter. Its total distance is 8 meter, but it's having two columns, one columns here and one columns here. So we have to subtract that one column. So after subtracting that one column, we have the total distance is 7.6, and width it will be same like 2.3, and it will be 1.5. So by calculating, we will get the final result quantities. The same way we will go for the next wall. This is the next wall, 9 meters. So this 9 meter walls, this one is the 9 meter walls, and this 9 meter wall is having just column will be here. So in that column, it's a 2 foot. It will be half. It means 200 mm will be in this side, and out of that 200 mm, 115 mm will be in this brick wall. So out of this 9 meter wall, we will say subtract 85 mm. So after subtracting 85 mm, we got this much 8.915 meter, and the width will be same 2.5, and the height also will be same 1.5. For this for this one wall 6.65 6.5 meters, we have two columns. One column will be at this corner, and one column will be at this corner. So in this corner, the column will be the column we have taken is for 0.4 meter. So in this column, the 0.4 meter or 400 mm. So column will be at the middle. It means uh, the bottom 200 to the middle of to the center of the wall. 200 mm column will be in this side, and 200 mm column will be in this side. So by subtracting this 200 minus the half wall distance, it will be 115. So after subtracting this one, we will get 85, but 85 mm and 85 mm will be also in that side. So by including both, it will be 170, and by here reducing 170, we will get 6.33. The same way we will go for the another wall of 6.5 meters. In that wall we have only one column. One column will be here only. This is there will be no corner. So the whole pillar or column will be outside. So and the column on this point will be in middle, so it will be bisecting half and half. So that way we will subtract only 0.85 mm from this. So after subtracting this one, we have 6.415 meter. The toilet walls are 4, 1, 2, 3, 4. In these the, in these walls we have one column at corner and one in middle middle. So corner column will not be added into the wall, and the middle one will take some brickwork of 85 mm. So that's why we will reduce that 85 mm. After reducing 85 mm, we have a 3.83, and this way we have four walls, one, two, and two that side. After a storeroom, we can see the storeroom. This one, the storeroom is having size 5 into 6, 5000 into 6000. In that 5000 we have two columns, one column this side and one column this side. So this column we will reduce that same 85 from this side and 85 mm from this side will be 170 mm. After reducing 170 mm we have 4.83 meter. And going to a library. This one is our library. It's 8 meter, or we can say 8000 mm. After reducing these two columns, it's 7.83 mm. It's 7.83 meter. So the same way we will take the dimensions. After doing all these calculations for the brickwork in the foundation, we will go for after doing the work we will go for the calculation, total calculation, multiplication. So no need to find those all the brickwork individually. If we have six walls of same size, that same thing, so we can find it for one, and we can multiply it with the numbers. So we have this. In foundation and below plinth level we don't have anything like a reduction of windows, because a reduction of windows and doors are above the plinth level. Below plinth level we have to do the brickwork for the everything, so there will be no deduction. After brickwork in the foundation, we are going to the brickwork in the structure, superstructure. The same way we will calculate the things. We have the same wall and superstructure, and the only thing we have in superstructure is this reduction, door reduction, window reduction, and other reduction like ventilators. So we have wall, same wall. The only difference is wall is increase, height of the wall is 1.15. Height of the wall is 2.55. So we will multiply with that height, and the same we have the same wall 0.23, because it's a school building. So we are not going to take that thick wall 115 mm. We are going to take that 230 mm thick wall. So the same number of walls will be there. The only it will be the height matter 2.5. After all the calculation, now it comes to our reductions. uh, Deduction are main door. We have main door. uh, we have main door here, and we have two local doors. One is there and one is there. So we will reduce that brickwork that door brickwork um, for the window, for the door. First we will reduce it for the main door, and dimension of the main door are already given. These are the dimensions for the main door. Here you can see the dimensions: 1.1 meter and 2.1. This is for the normal door, and the main gate is 1.5 into 2.1. So for that door we have this we are calculating for main door. We have two numbers, and This one is that 1.5 is the gate height, and 2.1 is the height, and 1.5 is the width, and 6.5 is the total height. So we will get this much work. Let me take you back this much. Now main door 1 number. Now total number of doors we will count. Every room and every staff room and library is having a door. So we will count all the doors. We have 25 doors. After calculations, we have the door size 1.1 into 2.1, and thickness will be the same because we are reducing. In place of bricks, we are setting doors and windows. So that place will be left out. It means that we are not using brick on that place. So we will uh, we will left that place. So deduction, that's why deduction done. Deduction means reducing the brick requirement. And if we have the doors, we are going to fix the doors on that place now in place of bricks. Now finally the total number of doors has been counted. It's about 20. It's about 1 minute. Yeah, total number of doors is 25, and total number of windows also calculated. It's 45. Window dimension are 1.2 into 2.1. 1.2 into 1.2. This is a ventilator size is 0.45 meter into 1.2, and thickness will be same. Total there are 3 ventilators. And after going to after this, we are going to calculate the total parapet wall. So for every room, calculating parapet wall is like doing calculation again and again. It will be hectic. And so we can calculate the whole boundary outside the window, just going from border window, because we cannot needed to use parapet wall inside because it's totally covered. So we will use the parapet wall outside. And for the total parapet wall, we have calculated the distance, total length, and we will multiply it with 1.5 115 mm, because parapet wall is can be kept thick and thin, means 115 mm, and its height is already its height will be like this one. Its height will be 0.9 meter, and this is in total. This was the done total. So after that, we are going to deduction is done for main door, windows, ventilator. Now plastering. So we are going to do plastering in, like, for every wall. We have the same wall length. We have the same height. Only we are going to do for every wall. We need twice, 2 times. And in that wall it was volume, but in this we have the area. So we will calculate the area, total area of walls for the plastering. Now area for all the walls is been calculated. Like wall will be the same, like all the rooms need to be plastered. The only difference is for every wall it will be double. So this is the dimension, this is the height we have taken, this is the calculation. These are the calculations. After doing this, we need to do the deduction for everything, every window, door, and ventilator. If because for ventilator and doors also, we will reduce to twice, 2 times the number of the windows and doors. So this is the deduction we did in plastering. And plastering, for every window and doors we have calculated the total area, and it is the total area of the building by minus the store deduction. After ceiling and painting. So in this our building plan, ceiling and everything is very simple. It's not like its inner area is given. Sometimes it's given total center to center, but in our drawing it's given the only center area. Otherwise walls are out of that area. So it's very easy for us to do calculation for ceiling. So we have did the calculation this way. It's a very simple calculation. And now finally we have the staircase. So for staircase we don't need to use ceiling. So to reduce the ceiling area, we reduce the ceiling area, and total ceiling area will be the total building area minus staircase. Okay, thank you.